Hello once again. This is the homework take-up for solving system equations. Okay, just one little note as I get into the questions from 11. I did get a lot of requests for questions from 11, okay, which I mean is totally fine. But I would like to remind everyone, like, don't forget that you do have access to the solution manual for the textbook, right? And if you've forgotten how to do that, just message me and I can show you how that works. Okay, but it does have the full laid out solution with steps there as well. Okay, so like I got requested, I think 6 or 7 things from 11. I'm just going to do 3 just to show the steps, and then do 12, 17, and 19 as well. Okay. So for 11F, okay, just to only classify these, I think this is one of the ones that turns out into point maybe. Okay, I don't know. I'm just going to focus on solving it. Okay, looking at the equations, I can tell they're not scalar multiples, so there's no parallel planes, so it's going to be type 3 or type 4. Okay, so I pick a pair and try to eliminate. So let's say if I was trying to use the first one and the second one, okay, I would need to multiply my first equation by 5. Okay, so equation 1 times 5. Okay, so that would give me 10x plus 10y plus 5z equals 50. Okay, my second equation would give me, so I'm going to do equation 2 times 2, so I get a 10 there. So 10x plus 8y minus 8z is equal to 26. Okay, so that leaves me with 2y, and I'm subtracting here, so that must be plus 13z is equal to 24. Okay. Now I pick a different pair. So let's say I picked equation 1 and 3 for my next pair. So I would need to do equation 1. I'm going to get that up to 6. So equation 1 times 3 is 3x, not 3, pardon me, 6x plus 6y plus 3z equals 30. And equation 3, I'm going to multiply that by 2. No. Yep, by 2. Okay, so 6x plus 10y minus 4z equals 12. Okay, and now I subtract, so negative 4y plus 7z is equal to 18. Okay, so this is my equation 4 and my equation 5. Okay, so to eliminate y, I would need to multiply equation 4 by 2. So 4 times 2 gives me 4y plus 26z is equal to 48. Okay, and negative 4y plus 7z is equal to 18. So that gives me 33z is equal to 66. Okay, and that's a good sign because it means z works out nicely. So z is equal to 2. Okay, and now I have z equals 2. You should be able to back substitute and figure out the rest from there. Okay, but again, we'll go through that quickly here. I had 2y plus 13z equals 24. So 2y plus 13 times 2 equals 24. This is equation 4. So that means I've got 2y equals negative 2. So y is negative 1. Now we'll solve for x. So let's take that first equation. 2x plus 2y plus z. Z was 2 is equal to 10. These will cancel out. So 2x equals 10. X is equal to 5. Okay, and we have our solution is 5, -1, and 2. Okay, and the system is solved. Okay, and a quick way you can check if you've got it, right, is just to go back. I plugged it into equation 1. I can now test it with equation 2 and see if it actually works, right? So I'd have 5 times 5, take away 4, it's 21, take away 8 is 13. Okay, it works. Okay, 11G. Okay, this one probably seems a little bit weird because I appear to be missing variables here, right? I don't have a Z here, I don't have an X here, I don't have a Y there. Okay, but we'll try to take the same approach, right? I'd like to get a pair of equations that don't have X. Okay, well, I do have one already, right? Equation 2 already doesn't have an X. Pardon me. Okay, right. So I really just need to focus on eliminating X from one of these equations. Okay, so we've only got 2 left. So let's do equation 1 times 7. So I have 14x plus 35y equals 7. And we'll do equation 3 times 5. Sorry, not 5, times 2. So that is 14x minus 8z is equal to 2. Okay, now I subtract those equations. I'm going to have 35y minus 8z, right? I can't combine those, is equal to 5. Okay, and now I'd be ready to go with my other equation. So this is my equation 4. Okay, now having a look here, okay, I have a 4y here and a 35y there. That is not nice at all. Actually, it should be plus 8z because I subtracted the negative 8 there. Okay, so I'm going to choose to eliminate z instead because it looks way easier to do. Okay, I'd have to multiply this equation by 8 in order to do that. So I'm going to keep equation 4 the way it is. 35y I'm going to do equation 2 times, so to get rid of z, so times 8. So 32y plus 8z is equal to 8. Okay, so y is equal to, I have 3y, no z, negative 3. So that means y is equal to negative 1. Okay, again, I think I'll leave that there because now we've got y, it's pretty easy to solve for z and for x. Okay, so yeah, notice I chose to do y instead of z because it was easier. Okay, you can do that anyway along here. Okay, back at the start, it probably would have been easier to eliminate z right away because I just multiply this by 4. But you don't have to start with x and then go to y and then go to z. It just, if you're looking for some, I guess, structure, right, a regular pattern, that's a nice way to do it. Okay, but yeah, that's how you can deal with that. I just needed some second equation that had 2 of the same variable, so I used these 2, and I got my equation in y and z. Okay. And here's why it's even stranger, because there's no x at all. Okay. But we have y and z, so let's try solving for y and z first and see what happens. Okay. Because one thing to notice here is that these 2 equations are actually the same. Okay, it's not totally obvious, but if I divide that first equation by 4, I get y minus z is equal to negative 4. And if I divide the second equation by 3, I also get y minus z is equal to -4. Okay, so this is actually a system of two planes, right? One of them is this same plane, okay? So that means these two planes should intersect in a line. That's really what I'm going for here, okay? So really now my system is down to just these two equations. Okay, my equation 1 was y plus 2z equals 11. Okay, and both equation 2 and 3 reduce to y minus z is equal to -4. Okay, so let's take a moment and solve that. If I subtract, the y's are gone. Okay, 3z is equal to 15. So z is equal to 5. Okay, solving for y minus 5 equals -4. So that means y has to be equal to 1. Okay. Now again, we found y and z. That's great. But what about x? Okay, it's not even involved in the equation here. So that's, I guess, kind of the trick that's actually happened here, because I don't know what x is. And in fact, x doesn't affect the outcome of this at all, right? Because it's not, doesn't appear in the equation. I know I have to use it because I have y and z. I'm in 3D. So this is where we're going to do a different parameter, right? I'm going to let x equal t, because it actually doesn't matter what the value of x is. It can be anything. Okay, and basically now I'm pretty much done. So the equation of my line is going to be x equals t, y equals 1, and z equals 5. Okay. So my vector equation x, y, z equals, again, this is always a little weird, 1, 5. Okay, my direction vector is just 1, 0, 0, right? Y and z had a solution, and it doesn't matter what x is. So I can't change y and z. That's why it's zeros in my direction vector. Okay, and then for this point, again, it doesn't really matter what x is, okay? Because the only thing I can change it with my direction vector. So to make it nice and easy, we'll call it 0. But I could put anything I want there for x, and it would still be valid. So this is the equation of the line. Again, it's 1, 0, 0, so it's parallel to the x axis. Okay, so it doesn't matter what value x is. Yeah, that's definitely a weird question, that one. But that's how you deal with it. With the missing variable, that will become my parameter. And I just make sure that I can solve the system. Okay. Okay, number 12 is a bit different. So it says students solve three systems of planes, and basically this is where they got to when they were solving it. Interpret how the planes intersect as exactly as you can in each case. Okay, so we can interpret how you can solve this. Okay, well, so the first one, I think that one should be fairly straightforward here. Okay, if they got down to x equals 5, y equals 10, and z equals -3, then these intersect at a point, right? My point of intersection is 5, 10, and -3. Okay, this was a type 4. Okay, the key thing with these two, okay, I got to my 0 equals 0 line. Okay, so from the previous note, that was what happened when you had a type 3D. Okay, right? Because I got to 0 equals 0, okay, that means that there's an infinite number of solutions, okay, and therefore they intersect in a line. Okay. Okay, for C, I got to 0 equals 12. Okay, that's the kind that doesn't make any sense. So this is most likely type 3A. Okay, that's when they meet in kind of that triangle formation. Okay, so that's what they were getting you to look at here, is that, okay, this is my point, my answer was a point. 0 equals 0 means that they intersect in a line, so it must have been type 3B. 0 equals 12 is that situation where you have type 3A. All right. Okay, on to number 17. Okay, determine the equation of three planes that are, and here's the different conditions for the different questions. Okay, so first, there is no single solution to this, but let's talk about what each one means. Okay, right, so part A, right, are parallel and distinct. Okay, so that is the whole type 1, okay, where I have three planes that are the same. Not the same, sorry. They're parallel and they don't intersect. Okay, so what could the equation of these planes look like? Well, I know that if they're parallel, right, that means their normals have to be parallel. Okay, so let's start with that. The normals of the three planes I'm creating have to be parallel to each other. So they have to be scalar multiples. So I could make it really easy on myself, make them all the same normal, or I could mix it up a little bit. So let's say, for example, I don't know, let's start with a simple normal like 1, 2, 1. So I could have x plus 2y plus 1z and equals something. We'll worry about the something in a minute. Okay. I can do a second plane that's also x plus 2y plus z. Okay, and maybe just have some fun. Let's make the last one, I don't know, 81x plus 162y plus 81z. Just multiplied my normal by 81. Okay. Okay, the second part is they're distinct. Okay, so I don't have the same plane twice. That means that my constants cannot be the same multiple. So in the first two equations, it can be simple as if this is a 1, the second one can't be a 1. So maybe it's 5. Okay, so these two planes are parallel, but because the equations are not complete scalar multiples of each other, they're distinct. They don't cross. Okay, same thing down here. All I have to be careful of is that the constant is not 81 times the constant of the first one. So I can put some other interesting number in there, like, I don't know, 75. Okay, and this will also not intersect. Okay, for B, I want my planes to intersect at the point 3, 1, and negative 9. Okay, so that means it's a type 4 because they intersected in a point. So let's just start by trying to develop one plane that would do that. Okay, so if I had x plus y plus z is equal to something, okay, I want to make sure that this point is on this plane. So I can use that information to figure out what the something is. So if you think back to when we developed equations of the plane the first time around, right, we would plug in a point to figure out the value of d in the equation. So that's what I'm going to do here. Okay, on the side here, I have x is 3, right, plus y is 1, plus negative 9. When I add those together, I would get 4, negative 5. Okay, so x plus y plus z should be negative 5. So there's an equation of a plane that has this point on it. Okay, so it's type 4. So that means that the other planes, okay, first they can't be parallel. So my next plane's normal can't be a scalar multiple of 1, 1, 1. Okay, so let's make it 2, 1, 1. Okay, so that's it. Okay, now once again, I've just got to make sure that this point is on the plane. So over here, I'd have 2 times 3 plus 1 plus negative 9. So now I have 6 plus 1 is 7. Take away 9 is negative 2. Okay, so that's equal to negative 7. Okay, so far these two planes, okay, are not parallel, and they both have the point 319 or 31 negative 9 on the plane. Okay, for my last equation, now this one I'm going to be really careful. Okay, because there's two conditions I have to meet. One is that it's not scalar multiple, I can't be parallel. So maybe I'll make something up. Let's do 1 and 3 and 2. Okay, again, I take a minute to figure out what my value would be for the constant. So I have 3 plus 3 times 1 plus 2 times -9. So that's 6 plus -18. Okay, it should be -12. Okay. The thing I have to watch out for is that these are not coplanar, right? That I didn't accidentally create a system that meets in a line instead. So I would need to do a little check, okay, and do the triple scalar product with these things and see what I get, okay? So I'll try to do that really quickly on the side here. My first normals are 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1, 1. I'm hoping these all come out to be positive because that would be really nice. Let's see. Well, 1 take away 1 is 0. 2 take away 1 is 1. And 1 take away 2 is -1. Okay, so if I take that and I dot it with this vector, 1, 3, 2, dotted with 0, 1, -1. Okay, that is going to give me 3 take away 2. It's 1. Okay, it's non-zero. So this was a type 4, and I'm good. Okay. Now, another way to make sure, instead of having to go through all that process, another way to think about it would be, okay, if they're coplanar, okay, that means that they are a linear combination of each other. So long as I can't add the first two normals together in some way. So if I start with 1, 1, 1, that was my first normal. Okay, if I added, say, 2, 1, 1 to that, okay, that would give me 3, 2, and 2. So long as I just tweak that a little bit, like if I made that 3, 2, 1, I know I'd be safe. Okay, that would work because it's not a combination of the other two normals. But again, those are the two conditions you had to meet. Okay, the point is on each of these planes. I checked the triple scalar product and it's non-zero, so it's a type 4. Okay, third one says intersect in a sheaf of planes. So actually, for this one, I had to look up what sheaf meant because I wasn't 100% sure. So when I went over to Google, it gave me this nice picture right here of sheaf, and you can see that they meet in a line. Okay, and honestly, I thought the word sheaf meant like a stack of paper. That's a ream, I think is the actual word for that. So I was thinking they were like coincident planes, but no. Okay, it looks like this. So that's a situation where the planes meet in a line. Okay, so we're really trying to build a type 3 system here, or type 3b. Okay, for C. Okay, how would I do that? Well, I would start by making up the equation of a line. 1, let's do something simple. 1, 1, 1 plus t, 2, 0, 1. Okay, so now the planes I make are going to have two conditions. Okay, one, they have to have this point. Okay, and two, they're going to have to be perpendicular to this line. Or sorry, the normal is going to have to be perpendicular to this line. Those are the two conditions. Okay. So, for example, the fact I have a 0 here kind of helps me a bit. If I made the first normal, let's say 3x plus y plus 6z. Okay, so my normal is 3, 1, 6. Okay, when I dot that with 2, 0, 1, okay, I get 6 plus 0. Oh, that is not going to work. Let's change that to minus. Okay, minus 6. That equals 0. Okay, so this direction vector is perpendicular to the normal, so this line can lie in the plane. It equals something. And now, same trick. I just need to make sure this point works. So if I put in ones here, I'd have 3 plus 1 is 4, minus 6 is -2. So that should equal -2. Okay, and now I just have to make two more planes that do the same thing. Okay, their normal has to be perpendicular to this. Okay, and they must include that point, and that's how you would generate the system. Okay, last but not least, we have number 19, which is the system of 4. Okay, this will take a while. So I think what I'm going to do today, I'm going to do the first couple steps here to show you what the process looks like. Okay, and then if you still can't get it to work out, ask me again tomorrow, and I'll put up the rest of it then. Okay, I did briefly talk about this in the video, but the idea with 4 is I have 4 equations, 4 unknowns. So my first goal is to reduce it to 3 equations with 3 unknowns. Okay. So I'm going to take the first equation there. So this is 1, 2, 3, and 4. Okay. So I need to take pairs so I can reduce it to equations with 3 variables. So for example, a nice one is equation 1 and equation 3. Okay, if I write out equation 1 again, 2w plus x plus y plus, this should have been 2z. Okay, 2z equals -9. And equation 3 is 2w plus x plus 2y minus 3z equals -18. Okay, so I'm going to eliminate w. And actually, it looks like it's going to get rid of x as well, but that's okay. So w's cancel, x's cancel. I have -y plus 5z is equal to 9. Okay, so this is my equation 5. Okay, let's find a different pair. So I could use 1 and 2 if I multiply equation 2 by 2. So again, equation 1 was 2w plus x plus y plus 2z equals -9. Okay, I'm going to take equation 2, I'm going to double it. So 2w minus 2x plus 2y plus 4z is equal to 2. Okay, and now we subtract. So my w's cancel. X minus 2x, that's 3x, y, 2y minus y, 2z take away 4, -2z, -9 take away 2 is -11. Okay, equation 6. Okay, and now I need another pair. So let's use 2 and 4 because I only have to multiply one of the equations. Okay, so I could rewrite equation. Let's see, I'll start with equation 4. It's 3w, and so on. And then I'm going to take equation 2 and multiply it by 3. So I get 3w minus 3x plus 3y plus 6z is equal to 3. Okay, let's cancel. 5x, y's cancel. Well, that's minus 5z is equal to -3. Equation 7. Okay, so I'm just going to try copying those out for a second here. But now I have -y plus 5z equals 9. So -y plus 5z equals 9. Okay, 3x minus y minus 2z is equal to -11. And 5x minus 5z is equal to -3. Okay, this is equations 5, 6, and 7. So I have reduced my system to 3 equations that have 3 variables. Okay, so basically now I'm back to the kind of questions we did in yesterday's note, and now you repeat the process. Okay, let's try to eliminate another variable. So I would work with equations 6 and 7, right? Multiply this one by 5, multiply this one by 3, so I can cancel x and then move forward from there. Okay, so that's what the rest of the process looks like. I got it down to 3 equations, 3 variables, and now solve. So I'm going to leave it there. Okay, see if you can solve it the rest of the way. And if you can, awesome. If not, okay, send me another message and I will finish that with tomorrow's homework. All right. Thanks for watching, and we'll see you at the next one.